All right, hello everybody. I hope you're having a wonderful day. It's just getting to have some sun disappear on us, and some clouds are coming rolling in here. So let's hope that we don't have any major issues with anything completely disappearing on us. All of our power kind of had a lovely cutout yesterday, and so we had some obvious challenges, but such is life. We're going to carry on here today. So we've got for ourselves, I've got a couple of different places that you can get involved. The first place is on Discord, which I see I have a couple of people who've already gotten in. So if you're on the Discord, fantastic. I am broadcasting the video only to the NDC Music TV because I don't want to have to worry about too much along the lines of lost video or lag or anything to that effect. So if you're in Discord, thanks for joining. You can listen in there. I am also welcoming any of your questions that may come up there, and I do believe we'll be able to pick up your sounds on the broadcast too. So if you ask a question, everybody's going to hear it. And then, of course, we're also on Twitch and YouTube. You can chat in any one of those places. So if you're on Discord, chat in the NDC School channel, or chat on the YouTube chat or the Twitch chat. Everybody will see all those chats across all of those places, so you can have a look at, or you can put your questions in there. I'll quite happily provide them for you, and we can even bring them up here for you without too much problems right onto the screen so that everybody can see the questions as we're going on too. There we go. We have ourselves moving now. The first thing I wanted to share with you guys was talking about dealing with rocks and such. I'm sorry, just for one quick second, I'm gonna mute somebody. It's making a little bit of extra background noise in the Discord. But you can always unmute yourself if you would like to ask a question. It makes things a little bit easier. Anywho, so students, I was talking to my family about the fact that we're dealing with rocks, and kids, they always like to collect rocks. So my youngest comes to me just yesterday actually and says, "So I have this rock if you wanted to show your students." So I'm totally going to do that. I'm absolutely going to show some rock to you guys that he brought up, because it's actually got some pretty good, interesting characteristics that will help you understand a little bit more about some of the different types of rocks that we have, perhaps. So the one that I have here, the first rock I have here for you is it's kind of a conglomerate rock. There's a whole bunch of stuff in it. You can see that there's a little bit of a lighter cream color, kind of dusty rock in there. That's the sedimentary quartz type rock, and then it gets into this metamorphic quartzite, the white stuff on top. There's also a thin layer of the gray ribbon that's going through there. That's actually slate that's in there. So we have a variety of different types of rocks in here, sedimentary and metamorphic, all into this one. This is the one that he brought to me. I'm like, wow, that's kind of cool. This is something that the kids might actually be interested in seeing. But you can also talk about the ways that rocks are identified by way of their luster, by way of their texture. This one here has some crystalline shine to it. As soon as I said, yeah, that one looks really cool, he brought out a whole bunch more rocks for me. And so I have one here that I thought was really interesting as well, particularly because it shows one rock being moved from sedimentary, and then it has to have gone through some sort of heat and pressure to get to this part here, which is a metamorphic version of the exact same rock. So heat, pressure on one thing being eventually shifted or changed into this melted, kind of swirly kind of texture that comes out on the top of it. At first he thought that this was like some sort of a dinosaur bone. It's not a dinosaur bone, it's just a rock that's gone through metamorphic change. That's it there. So that one was kind of cool. Then we can get into a couple of differences in here. So those were good examples of some sedimentary rock. I've got two examples here, excuse me, two examples here of igneous rock. So I've got one here that's actually kind of a lava bomb, if you will. And let's see if we can get you some better view at it. But this lava bomb, I don't know if you can see it very well. We don't have a whole bunch of really great light in here. But it's very porous, very light, and I could actually crumble this thing apart, but I think I'd have a kid really hate me if I did that, so I'm not going to. And right beside it, I also have one that is, this is obsidian here. It's really, really shiny. You can I hope you can kind of see a little bit of the shine coming off the lights here. I'll tell you what I'm going to do. I'm actually going to turn on a different light here because the cloud cover's getting rid of all my natural light. And hopefully you can see, oh, you can see a little bit of the glassy kind of look to that one. So that's your obsidian and your lava bomb, if you will. So this one would be a great example of intrusive igneous rock. This one was extrusive because it came out of the surface. So two different types of rocks there. And then we can get into some differences between sandstone, limestone a little bit here. So I've got a sandstone rock right here. This guy here, you can see a lot of the pebble makeup inside it, a little bit more of the grained kind of texture to it. This guy here is also a sedimentary rock, but it's got different chemicals in it. It's got limestone in it instead. And so with that limestone, we have, it's got like more calcium built into this thing. This guy here, if he goes through a metamorphic change, he can actually turn into this guy here. So this guy can actually turn into some forms of this quartzite instead. So these two guys are related. This is sedimentary, this is metamorphic. We get over to this guy here, and unfortunately, I don't have an example, probably because it's expensive, but this is limestone that could metamorphosize into marble. That's what you're most likely going to get out of that guy. So those are the rocks that I've got here that the boys have said, hey, why don't you share this stuff? And so I'm going to, but then my wife comes up to me and says, you know what, I got some pretty cool stuff too. And I'm going to hope that I can get a focus on this guy. But this guy here, in sedimentary rock, we have some fossils in here. And you can see the tiny little indentations right there and right there. These are shell fossils. And they're fairly shallow, so they're not going to be ridiculously old, only a couple 100 million years old. I'm kidding. Only somewhere in the neighborhood of 60 to 80 million years old. But these are shells that some of these kinds of organisms still exist today. We also have some example of some plant fossils and dragonfly wings. I don't know if we're going to be able to get a chance to see. Oh yeah, we could totally see it. So if you look really carefully, right in here, there's some ribbed lines in there. Those are actually in the shape of a dragonfly wing. And the wings were like big sucker wings. So these are going to be older than the dragonflies that we get today. You can also see right beside it, you can see this little vein like here. That's a leaf vein. So we actually have some rock leaves as well built in, leaf fossils built into this. And these are trace fossils. These are not the actual original remains. Well, actually that's not true. The leaf one is an original remain, but the imprint from the dragonfly wing, that's actually a trace fossils, just like the shells were. Those were trace fossils as well. And then I have one other original remains fossil that I'm going to share with you. It's this guy here. Now, he doesn't look like a whole heck of a lot. In fact, it kind of looks like somebody melted down some plastic and it kind of pooped out in a really strange way. But he is actually petrified wood. So what he has, or what this one is, and it doesn't even look like wood at first, but when you get to the middle of it, you can actually see this little circular portion right here. That's actually like the knot of a branch of a tree, of this particular tree. So this is petrified wood. It's super light. But all of the stuff that used to be the wood, the heartwood, the bark, the cambium and xylem and phloem, all of those proteins that come from that have actually been replaced with some minerals that have created this rock, which is what makes it petrified wood. So yeah, just wanted to share that stuff with you because we seem to have this collection growing at the house. But that's not what you're here for. What you're actually here for is the assignment. So that's totally what I'm going to switch to, is I'm going to switch myself over now to the assignment. All right, so in our assignment, we have one thing that you got to do, and it's a big assignment this week. So what I'm going to do for this particular live stream is I'm going to move into the idea of just walking you through this as if it was actually in the classroom. And then that way, if you have any questions, you can always ask me anything you would like as we're going along in the Twitch or in the YouTube, and I will pause for your questions as I'm going through this. I will also pause a little bit to help you guys have a bit of time to ask whatever questions, or to actually do the work while you're watching the broadcast. And I see that some people are in here as well, so thanks for joining in. Appreciate you guys watching along. Hopefully I can actually get you guys a good chunk of help out of this too. So we're going to switch gears here right now to the assignment. So this assignment here, this is the actual assignment that I sent out to you guys this morning. And what I'm going to do is I'm going to go one question at a time. If you have questions, and we're going to see them pop up here into the chats, and we can see a couple of people have already started to throw some things into the chat. But if you do have questions, we're going to leave that sucker up there so you can do so. What I've done is I've kind of made this imaginary space where you have been put in charge of trying to compile data that's going to convince people to say this area of the land needs to be protected. So what has actually happened, the background of this story, it's totally make believe. I did not actually steal this from real life. This is all just out of my head, I promise you. But if you look at this particular diagram, this one right in here, the colorful, weird, wavy looking things, you're going to see that inside this diagram we have a bunch of different rock shapes or rock layers and such. One of them, I'm going to have you just kind of take a peek at it. There's a little black blob on the left-hand side. It's labeled D. That's an oil deposit that in the story of this assignment was discovered a few decades ago. And they started hunting around for some more oil deposits, and they didn't find much. What they ended up finding instead was a whole bunch of fossils. And so what you've been tasked with by a government organization, we'll say, is trying to determine how relevant this particular area for fossil finds is and whether or not it needs to be preserved so that it doesn't get damaged. That's the idea behind this assignment. So we're going through basically one question at a time so you can identify some of the different things that were built into this project and different things that exist in this makeshift make-believe place. So the first question up there, you can see it right now. That first question is, what type of rock do you think the rock labeled G is? Do you think it's sedimentary? Do you think it's metamorphic? Or do you think it's igneous? And then you also have to explain why you think that. And so the G one is the red chunk that kind of goes straight up the middle of the diagram. So that's G. So what kind do you think that one would be based off the knowledge that you have from what we've discussed in the past month? Sedimentary, metamorphic, or igneous? And this is where I'm going to pause. I'm going to give you guys a chance to actually put this right into your assignment, and then you can ask if you have any questions. You can throw it on here. Question that's already up here. Well, how many questions there are? There's 13 questions. My lucky number 13. So you might actually want to break this up across a couple of days of work, but I'm going to give you a bit of time here that you can put some more effort into this now, or at least get an idea out there for you. All right, I'm not going to give you a ton of time. I'm just going to give you a little bit of time for the questions, enough that I think that you can at least get a start on your answer. My important one on that last question, number one, is the fact that it has to have a Y. Well, and if you're looking at that rock, this is a good question. Would the rock that is G be a metamorphic rock? So I'm not going to give you the answer on that one, but what I am is going to kind of guide you to an answer on that. So in this case, the letter G, it's on that red strip. If it was a metamorphic rock, it would have to have been a sedimentary rock at some point in time. So it would have had to have been a layer of some sort. And then it would have had to have had a whole bunch of heat and pressure put onto it. So it still would probably be a kind of layer of some sort, perhaps. But it would also have to be nearby lots of heat. What kind of place would you get lots of heat from? So if it's metamorphic, you have to be able to say this is where the heat came from. If it's sedimentary, you have to say this is how the layers happened. If it's igneous, you have to explain how did the igneous rock get there from, remember, it comes from the mantle, it comes from magma and such. So how did the igneous rock get there? That's what you have to explain for question number one. So now we can carry on to question number two. And question number two has got a couple of parts to it, but we're going to go one step at a time on it. So question number two, it's pointing out the rock in section H. So first of all, I got to find where section H is. So section H is kind of beside section G, and it's near the bottom. It's kind of got this pinky color. Kind of in the middle, it's purplish, kind of in the and then blue, and it's kind of like has different shades all up that H section. So if this was G right here, then H is this, is this section right here. It just kind of goes right beside G. And so what you have to say is if you look at H, it actually has different layers to it. Where it is beside layer B, which is the yellow layer, or layer E, which is the orange layer, it's sedimentary. It is, that H level is quartzite. And then if it's beside, where it's kind of attached to layer C and to layer F, it's actually made up of marble. And it's kind of fun that we actually did this because I just explained to you some of the different minerals or some of the different rocks that my son kind of showed you. And this guy right here, that's actually the quartzite. I don't have marble, but I wish I had that for you. But that's the kind of rock that you see, just kind of alongside G. Okay. What kind of rock is that, first of all? Is it sedimentary, is it metamorphic, or is it igneous? And you don't have to explain why, you just have to say which one is it. If it's quartzite or if it's marble, what kind is it? You can look at Google. I actually even said, research quickly what types of rocks quartzite and marble are. So go ahead and look those up if you would like, and then you can put your answer in there real quick. All right, and we're back for the next one. So let's work under the presumption you already know what the answer to that one was. Knowing that, geologists studying this area have concluded that that rock, that vein of H, came after G made. So G came first, and then H came afterwards. Why would geologists say that that's the case? What would make geologists think that the H part would have come after G would have come? At which point you kind of have to think about, what was G again? Why would that have created H afterwards? Okay, and then again, I'm going to give you a bit of time to try and get a couple of points out onto that for you. All right, and we're back. So there was a good question while we were off a little bit. The answers to this, all of the answers here, they might not be exactly the same from student to student, because what you're going to be doing is kind of explaining your answers based off of knowledge that you have. Some of those questions, there's an obvious correct answer to it. Like question number 1, there was an obvious correct answer to it. Question 2A, there's an obvious correct answer to it. But question 2B, that's going to be a little bit more of you trying to apply what you know and giving your own answer. If you can argue your answer appropriately with good science, then you can get marks. So every student's going to have a bit of a different answer. So the question, is there an answer key? The answer key is your head. So if you've got this kind of going well if you are able to take what you say and prove it with some of the other facts that we have in the assignment, then you're going to get the marks. It's kind of nice that way. So okay, so that was question 1 and 2. Now we're going to carry on to question number 3. Question number 3. So geologists know in this example, in this particular fake fake assignment. Geologists know that all rock in this area is either sandstone. Okay, yeah, all the rock in this area is either sandstone or it's limestone. Now, sandstone sometimes includes mudstone. That's just a fancy way of saying sandstone that used to have lots of water in it. Either way, it's sandstone or limestone. So what do you think that each one of those parts of H is? So if you look at H there real quick, the bottom chunk of H is kind of a pinky color. Then the next chunk up is purple. The next chunk up is blue. The next chunk up is, I actually can't even see it from here. It's going to be another color. And they kind of match the other layers. Like the pink section matches layer F. The purple section, it matches layer E. The blue section matches layer C. The next section up matches layer B. And so if that's the case, and you know that the section beside B, that section there was quartzite. The blue section beside C, that section was marble. The purple section beside E, that section was quartzite again. And then the pink section nearby F, that section there was marble again. If you know that, then you can probably figure out which kinds of rock were at each of these layers. And so what you're going to do, and you're going to do this with your Google Classroom, right into the file. If you're using the file to do this, then what you're going to have to do is highlight your answer, and then of course color the background of it, whatever color you want to make it, to make sure that I know that's the one that you're choosing. So for layer B, do you think it was sandstone, or do you think it was limestone? Highlight it and then color it, and that'll be how you answer this question. And you'll have to do that for layer B, layer C, layer E, and layer F. So I'm going to give you some time to go ahead and do that too. All right, and we back. So just as a quick reminder, if you want to go for a little bit more information, or if you want to look a little bit more carefully at that, remember that back up, and for question number 3, if you go back all the way up to question 2, it tells you what those were. So the part of the section of H that was beside layers B and E, those were quartzite. So if you can figure out what makes quartzite, what sedimentary rock makes quartzite, then you can put the right answers in for question number 3. So use the information from question 2 to help you answer question number 3. All right, we're going to carry on. So here comes question number 4, just motoring along. So question number 4. So geologists have studied the rock at layer A. So that's the very top, the pink section at the very top. Okay, it is the uppermost layer. That's kind of the top of the crust. That's where you would walk. They have determined that the rock of layer A, it actually matches a mountain range 60 kilometers away. So why would rock that comes from a mountain range 60 kilometers away be at this particular location? How would it have gotten there? And that's what I want you to take care of on this question number 4. How did the rock get from the mountains to this place here in this diagram? Ready, to go? All right, and we are back. So that question number 4 can pretty much be answered all by itself. You don't need any other information from any other location except for that picture that you see on the screen right there. Question number 5. So again, geologists, they were able to discover that whatever way the rock in layer A got there, however it got there, it accumulated at this location around 120 million years ago. But there hasn't been any other rock that has developed up on top of it. So it's like the top layer, nothing else has come on top of it. This is where you get to kind of give me some of your ideas as to why that might be. Why did that rock become the last set of rock that actually became rock there? Ready, set, go? Okay, now I may be moving a little bit faster than you guys are ready for. If that's the case, that's fine. Just kind of put some ideas down in each of these questions and then kind of move on. You can always come back and put some more detail in afterwards. And I do like the detail. The detail allows me to find fun ways of getting you marks. If you just simply put in a 1 or 2 word answer, then I can't find the way you were thinking and therefore give you marks for it. So the more detail you put in there, the better your marks are likely going to end up being. Okay, so that was question number 5. Let's move on to question number 6. Now we get to start talking about the fossils. Woohoo! There are fossils in this diagram. It doesn't look like it very much because it's totally just examples. It's totally just markers on there, just locations on there. But that's all right. So this next one, a fossilized skull of a wolverine-like predator was found at location 3. So first of all, figure out where location 3 was. It matches a cousin species to some of the first known mammals. And other similar discoveries were found in the nearby mountain range. Remember that mountain range we said that layer A came from? So there were some other wolverine-like predators found there too. So how did the fossil get from there to here? And how old do you think the fossil probably is, if that's the case? Now, just as a fun little side note, I'm going to let you do some work on this in a second, but this is an actual, I did actually take this information from a real fossil that has been found that kind of links mammals to the reptilian ancestors that were previously here. It looked like a wolverine, but it wasn't actually a mammal. It still actually laid eggs. So it was very similar, but it was just like a cousin to the first of the kinds of mammals that ever existed. So there you go. That's just some fun facts for you. In terms of this question, how did the fossil get from the mountains to this location? And then how old do you think the fossil probably is based on that information? Ready, set, go. All right. I kind of think, yeah, pause champ, thanks. I kind of think that that might actually be the easiest of the questions for the assignment. So now we're going to get into some of the more tricky ones because you're going to have to pull some information from here and there and so on and so forth to try to get to the right answers. So if you do have questions, please plug them in the chat. I want to be able to answer them, and I'm here right now to be able to do so. So feel free to plug them into the chat. And if you end up watching this as a rebroadcast again later on, you can still send me questions by way of Google Classroom. I'm going to suggest if you haven't watched the video, you should watch the video first again anyway. But yeah, so we're going to make this as accessible as we possibly can for you guys. Okay. That was question number 6. Let's move on. Question number 7. We're getting to the interesting stuff here now. A Diplodocus. A Diplodocus skeleton was found. It wasn't in a perfect shape. It didn't actually look like the full-size Diplodocus, which is a huge animal, or was a huge animal. It's actually had all its bones up in a pile, and those bones were found in this disarticulated pile at location 4, which is kind of right near the middle of the diagram in the yellow. Now, Allosaurus eggs were found in a nest site. It looked like a nest. So this is trace fossil as opposed to original remains at location 5, which was, and actually I'm not mirrored, so it's actually on the other side of the yellow line. So what I'm going to ask you to do, or what I did ask you to do, is go research when those two organisms lived to provide a suggestion on how old those fossils must be, and then as a result, how old layer B must be. So this is going to take a little bit of work. Here's what you're going to have to do. You're going to have to open up a window, and you're going to have to go to Google, and you're going to have to search, when did the Diplodocus live? Then you're going to have to search, when did the Allosaurus live? And the reason why you want to look at both of those is because they were both buried in, or both fossilized in, the exact same layer of ground, the yellow layer, the layer B. And so you need to try and figure out a time when both Diplodocus lived and Allosaurus lived. And when you find, and it might not be an exact year, of course it's not going to be an exact year, but you can get approximately. So if you simply said approximately so many million of years ago, that'll be plenty good enough. So go find the Diplodocus, find the Allosaurus, find out when they existed or when they coexisted, and then that will help you provide your answer. So I'm going to give you a little bit of time to go and Google that up right now. Here you go. All right, so if you have gone to Google and you've looked up to see when the Diplodocus lived, when the Allosaurus lived, then you should have kind of a good range, generally speaking, of when layer B probably buried those fossils. So that was question number 7. All right, let's count we on to question number 8. This one's kind of interesting. And I can't remember what the fossil was called. It's like Flagellicodicus or something like. I can't remember exactly what it was, but a dinosaur fossil was found at location number 1. So it's the white circle right nearby the X, kind of underneath 4. So location number 1, there was a dinosaur fossil found there, and it looks a lot like Diplodocus, but it isn't Diplodocus. It had smaller forelimbs, smaller arms. So if the Diplodocus's arms were like that long, then this other fossil's arms were a little bit shorter, but the rest of it looked fairly similar. So what I'm asking you to answer for question number 8, and again, this is based off of your understanding of the science that we've discussed this unit. Why do you think, or what is the relationship between the fossil at location number 1 and the fossil that was at location number 4 above it? What's the relationship between those two? Okay, ready, set, go. All right, that should be good for question number 8. Let's carry on. Now we're going to get into question number 9. So this one's kind of interesting. Usually when we think of fossilized insects, we think of the mosquito stuck in amber from the Jurassic Park movies. But that's not the only kind. I showed you a little bit of a dragonfly kind of fossil that I have here at the house. So I kind of used that for the assignment. Here we go. Number 9. A fossil outline of a dragonfly wing that was 15 centimeters long was found at location 2. So here's just a little bit of information about that so you can see. This is around 30 centimeters. So 15 centimeters long, like that's long. That's a very long, and that's just one wing. Put 2 wings together, and that's how big the dragonfly was. Anyway, so predict how old that dragonfly wing would have been using information you've already learned about this layer and some other related fossils. Now, this is a question you might need to come back to because you only know a little bit of information so far. You know that layer B was a certain age, but you also know layer D was a certain age. So perhaps you can come up with an answer for when the dragonfly was put there. You might also be able to put some information there based off of what you learned about or what you discovered about number 1. But you may also decide that this is a question I got to come back to. So I'm going to give you a couple of moments to try to get some ideas as to about how long you think it's supposed to be. And don't forget the explanation of question number of layer D. That's at the very beginning of the file of your assignment. Way. Oh, that was the wrong way. I'm going down. Let's go up. Okay, yeah, it was all the way up. That was too much. Sorry, guys. It was all the way up here. So it's saying that layer D was 210 million years old. So you can use that information to say, okay, if layer D was 210, then what about the dragonfly wing, which was over here? Okay, so that's what we're doing with question number 9. It takes a little bit of work on that one. So I'm going to give you a little bit of time to go ahead and do that. Here we go. All right, so for that one, you should have had a look at how old fossils 4 and I think it was 3, something like that. I can't remember. What were they? They were fossils. Yeah, no, 4 and 5. The fossils 4 and 5. That they you should know how old they were. You can say I know how old layer D was, and if I know that, then I should be able, because of how stratification works, I should be able to figure out how old the dragonfly wing was at location 2. All right. Next question was number 10, and this one's got a few parts because it's going to deal with the same 2 fossil sets for a little bit here. So the ones that we're going to be looking at are the one here, there, the one on number 6 and the fossil at number 8 as well. So those 2 fossils, they're both in the gray section. And at number 6, amylite was formed. So now amylite is more of a rock type thing, a crystal type thing. So what I've asked you to do is take a couple of moments and do some quick research to figure out what fossil amylite is formed from. So what animal was amylite at one point in time? Once you figure out what that species was, figure out about how long it lived for, or what time it lived for, how many millions of years ago it lived for, and go ahead and plug it into that question 10a. So you're going to Google, you're going to find out what makes amylite and when did it exist. Ready, set, go. All right, that should be enough time for you to at least get a bit of a start going on that. Let's carry on, shall we? So we talked about the fossil found at number 6. That was the amylite. So let's go have a look at fossil 8, which is what is asked of you in question 10b. So at location 8, which was over here on your picture, on location 8, there was a small patch of trilobite fossils. So I'm going to ask you to do, again, a little bit of a quick Google search to find out when the trilobite lived, and then mark it in that little space there. Okay, so this is a quick question here. So find out when the trilobite lived and mark it in there. Ready, set, go. All right, so that was question 10A and B, and as you saw, I just put it in the chat. There's a right answer for those two, but there is not one specific right answer for this next question. So here we go. So we're going to pretend that you have a colleague, a coworker, who's helping you out on this project, and this colleague suggests to you that the separation of the rock layers E, which is the gray one, and sorry, E is the orange one. Sorry, E the orange one and F the gray one, that the reason those two layers got separated was because of a mass extinction event that happened around 250 million years ago. And when we say mass extinction, we're not just saying one species, we're saying at that particular one, it was around 90% of all living material on Earth died. So it was lots of extinction that happened at around 250 million years ago. They actually have a special term for it, like Precambrian area kind of thing. So 250 million years ago, mass extinction event. Your colleague says E layer, which is the orange one, and F layer was separated by that extinction event. If you looked at the fossils of 6 and 8, would that make sense? Does that support it? And if it does support that idea that your colleague has suggested, why does that support it? How does that support it? Ready and break. All right, a little piece of information that might be a little bit more helpful for that one too. If you wanted to go back and do a quick little adjustment to it, you certainly can, but keep in the back of your head, in order for an organism to become a fossil, it kind of has to die. So level 6, fossil 6 and fossil 8, they will have had to have died in order to have been put into layer F. Is that supportive of the idea of a mass extinction event, or could they have died at some other time? That's what you're going to have to try and answer a little bit in question 10C. I think you will have had enough time to do that, so I'm going to carry on. Booyah! To question number 11. The footprints of a turtle species was found at location 7. And this matches a shellless turtle species found at other parts of the world. So think turtle with no shell. Okay? The other shellless turtles were determined to have lived around 240 million years ago, the ones at other locations. They lived 240 million years ago. But this location's in the middle of Alberta. How did that one, location 7, it's in that big part of the orange layer E, 240 million years ago, how did that guy get there? It's a turtle. That's amphibious. It's not a land animal, especially the ones without shells. They don't live on land. So if they don't live on land, how'd they get to the middle of Alberta 240 million years ago? That's what question number 11 is asking you. Okay? So question number 11, looking at fossil number 7. How did an amphibious aquatic animal, a water-living animal, end up in the middle of Alberta? Ready, set, go. Alrighty Dan. So, question number 11. How did a water-living animal like a shellless turtle end up in Alberta? That one, it brings us to one of the more interesting questions in here. This was a little bit of reading in here. By the way, if you're not a fan of listening to my voice read these questions, you can of course get Google to do that for you. Use the Google Read Write feature and just have it read it back to you. It's perfectly fine. Okay, so question number 12. The most compelling reason to preserve this area is a fossil that was found at location X. So location X is right underneath location number 1 in the orange section, right near that top kind of, top kind of little hump in it. So this fossil is an incomplete fossil that matches another one of what's called the, not that this matters, but the Megacarilla wachtleri. The only other known fossil of this particular creature has been found in Italy. And so one of your coworkers suggests, one of your colleagues suggests that it's not the Megacarilla wachtleri because it matches other similar reptiles that lived at the same time as the Patagosaurus, whose skeleton was found at location 1. So now you know what that skeleton was in location 1. It was a Patagosaurus. So that means you're probably going to want to look up the background information on a Patagosaurus. When did it live? So, and then they think that your coworker thinks that this was a reptile that lived the same time the Patagosaurus did. But the Italy sample is suggesting that perhaps it lived around 240 million years ago. The one that they found in Italy lived 240 million years ago. This one lived, but your friend is saying, no, that's too old. It lived when the Patagosaurus lived. Which is right? Okay, either your friend is right who says that the fossil at X lived at the same time as the fossil at 1, the Patagosaurus cheapers, or it lived 240 million years ago like the one they found in Italy. Which one is right and why? Good to see you coming, those of you who are joining in. Thanks for jumping in. If you, just as a quick little reminder, what I'm doing is I'm pausing so that you have a chance to answer those questions directly into your assignment. So again, this question number 12, this is a bit of extra work you get to do on this one because you're going to need to look up when the Patagosaurus lived, and then know that the Megacorella got it, yes, lived 240 million years ago. Your friend, your coworker says that this fossil X had to have lived when the Patagosaurus lived in number 1, but you're suggesting it lived at the same time as the Italy one. Which one of you guys are right? Go ahead and answer that and explain why. This is a big question, so you'll need to get into this one in a big way. Ready, set, go. Alrighty, and we are back. So question number 12 is a bit of an involved one, and that's why I gave you a good solid pause on that. You're welcome to come back to it and add some more to it as well, but I want to make sure that my stream doesn't go crazy long, so I'm going to carry on to the next and final question. And then, of course, you can come back and finish up an answer to question 12 if you need to. So here we go. Question number 13, lucky number 13. This is the last one. So now that you've worked through all of the information, all of the fossils, all of the different layers of rock and the different types of rocks, you should be able to make some predictions about the order in time that the different sections of the rock were formed. So what I'm going to ask you to do is list them in order from newest to oldest in the table that you see here, okay? And I'm going to give you a hint, it's not 100% alphabetical order, okay? So don't let yourself fall into the trap of just going A, B, C, D, E, F, G, H. I don't think there's an H. Yeah, there is an H. Don't go all into that trap because that is not quite likely to be the right answer. You'll have to try and go based off of what you've learned about each of the fossils and about the types of rock that exist there. You may also want to have a quick look at G and say, how could it possibly have gotten the way that it did, unless it formed at a specific date. Okay, so have a look at that and go into it. So this is where you're going to do it. What you're going to do, you're going to go for your newest layer, which I'm going to give you a hint. This is an on-video hint. I'm giving you a mark right now. 120 million years ago, that was layer A. Okay, so that one is what you're going to put in there. Then you're going to put whatever you think came after that and when it probably existed. You might have to go with a range. You might not be able to say exactly this many years ago. You might have to say somewhere between 120 million years ago and 150 million years ago, or whatever the case may be. It's up to you. But either way, if you go with a range, that's perfectly acceptable. You're allowed to do that, okay? And that brings you to the end of question number 13 of the entire assignment. So that's question number 13. I'm going to give you just a couple of moments to go ahead and kind of get started on that. Ready, set, go.